Good morning or afternoon, whenever you're watching this. So, we're going to have notes 9.08 that we're looking at today, and we are going to start here with the warm up. There's some skills we want to review before we jump into today's lesson. So, here we're going to review the three trig functions for angle theta. Values must be in simplest radical form. So, simplifying radicals we're going to focus on. So, from theta, we know that one is the opposite side. 2 is the hypotenuse, and the square root of 3 is our adjacent side. And SOHCAHTOA is our acronym, SOHCAHTOA. So for sine, it's going to be opposite over hypotenuse, will be 1 over 2. Cosine is adjacent over hypotenuse, is the square root of 3 divided by 2, and that's okay to write it. We like radicals in the numerator, not the denominator. But looking at tangent, its opposite over adjacent is 1 over square root of 3. Now this we do have to rationalize, so we're going to multiply through by the denominator, which is like multiplying by a 1. And what that does is it makes our numerator into the square root of 3, and our denominator, radical 3 times radical 3, simply becomes 3. So now those are our three ratios for theta. And use any one of the above ratios to find the measure of angle theta. So when we're finding an angle, that's when we use our sin to the -1, cos to the -1, or tan to the -1. So going into the calculator, since sine is the simplest version, the sine of 1/2, I'm going to do that there. So again, when you have to find an angle, we're going to type in the angle theta. Again, that's just a Greek symbol. It's like kind of putting like an X. Equals sin to the -1 of 1 divided by 2. So in the calculator, second sine 1 divided by 2. And we should get 30 degrees. So again, double check you're in the right mode. It doesn't really. Some of you I know in the habit of resetting your calculator often, so you just want to make sure you're in degree mode. So that means angle theta is 30 degrees. Number 2, solving for a H triangle. We're going to draw a picture here. So we have triangle ABC. Angle C is our right angle. Angle A is 72 degrees. Side little c, remember, is opposite angle C. So that's going to be the hypotenuse will be 25. And we're going to find all the other measures. So to find the angle at B, we know it's the complement of angle A. So if we take 90 minus 72, yeah, angle B is 18 degrees. And if we needed to find side little a, we're going to set up a trig function. So and now it's not going to matter which angle we use. I'm going to stick with the 18 for right now because A is going to be the adjacent side. 25 is our hypotenuse. So we can set up a trig function with cosine adjacent hypotenuse of the 18 degree angle is A over 25. And into the calculator, when we cross multiply, we're going to have 21 times cosine 18. And side A will be about 23.7764. Now it didn't tell us where to round to here. I'm going to go 4 decimal places out, and then I'll approximate for now to 2 decimal places. That's the most precise. So side CB will be around 23.78. Now to go over and find side AC, I'm going to put an X here. I'm going to set up another trig function. Now I'm going to try to avoid using the measure I just found because if I had done some sort of calculation error, it's going to affect their next answer. So to find side X, again I'm going to focus on my 18 degree angle. We have X is now the opposite side. So we'll use our sine function. The sine of 18 degrees equals x to 25. Cross multiply, we get 25 times sine 18 will give us that x is 7.2542. Now to double check our work here, I'm going to actually verify this work and use our Pythagorean theorem. So if I go up and grab this answer and square it, and go up and grab this answer and square it, I meant to add, but if I take a squared plus b squared, second, sorry about that, I should get 625, which is equivalent to my hypotenuse squared. Now it's a little bit off because of our rounding error there, but it does work out. So we know we found all the sides correctly. Now on your papers, I'm going to add a question here. So if we want to call this maybe 2b, I do want to solve for an angle. So if I give you a right triangle, tell you that the side here, let's call it again ACB. If I want to say AC is 17, so again, this is a made-up problem, and side AB is 54. In this case, we would use the Pythagorean theorem to find the third side. Okay. But what if they're asking us for the angle measure? So if they want to know the measure of angle B, let's call that theta, and again, that's just a Greek symbol to represent the angle of B. If we wanted to find theta here, I would use a trig function. Opposite and hypotenuse would indicate we need sine. Theta equals 17 to 54. And again, when we're solving for the angle, we automatically jump to sine to the negative 1 of 17 over 54. There weren't many practice problems on your homework solving for angles, so I did just want to kind of roll back to that here. So second sine 17 divided by 54, so then the negative 1 I take in the second first. We should get approximately 18.35 degrees. Now that's if we had to round to the hundredths place, let's say. But sometimes they might ask for degrees, minutes, and seconds. So if I kind of amend my directions here, find theta to the nearest minute. This is what we'd have to do in our calculator. So here we have the 18.34, and we're going to go into our angle menu, so second apps, and down to choice 4, degrees, minutes, seconds. This is going to round to 18 degrees and 21 minutes because the seconds over here is bigger than 30. So this will round to 18 degrees and 21 minutes if we had to. Continuing with the warm-up, I want you to pause the video and try to rationalize these radicals. Also, if you'd like to try factoring number 4 and number 4a and 4b, those are p's and c's factoring. So I'd like you to attempt them first. So again, please pause, and then you can go on with watching the video to see my work done out. With letter A, go back with us. We're going to multiply by radical 2 over radical 2. So we'll have 12 square roots of 6 divided by the square root. I'm sorry, not the square root anymore, just the 2. Divided by 2. And that 2 will cancel your 12 and become 6 radical 6 as an answer here. So when you're multiplying radicals, radical 2 times radical 2 is technically square 4, remember, becomes 2. So our answer here should just be a 6. Moving down to review of factoring. So our p-value is what we multiply the 6 to negative 5, becomes negative 30. And our c-value is going to be 7. So we want numbers that multiply to 30 and add to make negative 7. And that's going to be positive 10x and a minus 3x, are two factors. So how that works is we're going to take this 3 terms and we're going to do what I call split the middle. So the 6x squared stays, but to rewrite 7x, we're going to rewrite it as 10x minus 3x, and then we're going to bring down that minus 5. So I made our 3 terms into 4 terms. What that allows us to do is factor by grouping. So we're going to group the first 2 and group the second 2. When I group the first 2 terms, 6x squared plus 10x, we're going to find the GCF is going to be a 2x. So we're going to divide 2x from each. So we write it as 2x times 3x plus 5. Now looking at the second 2 terms, we have negative 3x minus 5. Now we want to make that a positive 3x. So we're going to divide each piece by negative 1 as a GCF. So negative 1 pulled out gives us another 3x plus 5. So final step here is to take the GCF from the first binomial and this GCF for the second and make a magic binomial. So our final answer is the product of 2x minus 1 times 3x plus 5. And we're going to stop here because this question specifically asked us to just factor. So remember, factoring stops at the double bubble, essentially, these 2 binomials. If we had to solve, it'd be an equation. So it would have said maybe 2x minus 1 times 3x plus 5 equals 0. Then we would go and continue to solve. And in this case, x would have been 1/2 because you add the 1 over and divide through by 2. And the other answer would be x equals negative 5/3. Again, it didn't ask us to solve, so that's not what we're going to do in this case, but for the most part, we end up solving with the questions we have. This is really just practice to make sure you're confident with your factoring. I'm going to go a little bit faster here through letter B, but the p-value should be negative 120 combined to negative 7. And if you struggle with your factors, the little hint that we've given along the way, and this doesn't matter what mode you're in, is if you put that negative 120 divided by x into your calculator, you can pull up all the factors that multiply to 120. And now we're trying to find a set of factors that add to 7. And that looks like this 8 and 15 here. So we would branch this to negative 15x plus 8x, where those 2 digits multiply to make negative 120 and will add to make a negative 7. So rewriting 12x squared minus 15x plus 8x minus 10. Now, it doesn't matter what order these are in. The factor by grouping will always work itself out. So here we have a 3x that divides into each term nicely. And then 4x minus 5 would be left over when we divide each of these by a 3x. Over here, we're going to take out a 2, positive 2, and we'd be left with 4x 5 as well. So then the magic, we group the 2 GCFs as one binomial, so 3x plus 2 times the 4x minus 5 are the 2 factors. And again, we're going to stop there. So that's just a little bit of review that we're going to need moving into our notes for today. This table of natural logs actually helps us for our first notes page. So I believe you got this table. It might have been separate, but a little hint here is going to be, I don't know if this is a highlighter or not. I'll just underline for now. If I look at sine of 10 degrees, let's go up a little bit higher. Let's look at sine of 15 degrees. Is this 0.2588? Now, I find that over here as well. So I'm just kind of going down the sine and cosine column. We're going to be comparing find cosine today. So looking down at sine of 15 degrees would be this decimal equivalent. You can always test that in your calculator. Sine of 15 gives you to 4 decimal places the 0.2588. Also, cosine of 75 gives you the same decimal equivalent. If I typed in sine of 50, what do we think that would be equal to as a cosine function? So if I do sine of 50, and they're both not going to be on their screen here, we get the 0.7660. We scroll a little bit. We're going to find the same decimal down the cosine column at cosine of 40. So what that tells us is that sine, S-I-N-E, and cosine, C-O-S-I-N-E, are what's called co-functions. So moving forward to notes 908, sine and cosine are called co-functions. What that's going to mean is that sine of a value, let's say 30, always will equal cosine of its complement. So that the sum of this 30 and this 60 are complementary angles. So that's really the rule I'm going to give you. I'm going to kind of skip ahead with a lot of this because I know the notes are just going to take a while. But using that rule for number 10, if sine of 20 is 1 decimal equivalent, cosine of 70 is going to be the other, where 20 plus 70 equals 90. So here, if we have 33, we could go and take 30, sine 90, subtract 33, and we'll get 57. And we could test this, that if we typed in sine 33, we could use the table. We used that old school table back when I was in school. And cosine of 57, we find they're the same decimal equivalent because these two digits are complementary. So sine of 45 and cosine of 45 will be equal. So based on the findings, we can see that sine of x equals cosine of 90 subtract whatever x is. And reverse scenario, cosine of x equals sine of 90 minus x as well. Now to solve for x, using this little rule, the best suggestion I have that'll work for you nicely every time is to take these two numbers that are inside and sum them to 90. So x plus 31 equals 90. Therefore, x is 59 degrees. Same thing with our number 12, 75 plus x equals 90 would make x 15. And if they give you a little expression here, again, the best case scenario is to take the x minus 4 plus our 50 equals 90 and solve for x. So we subtract that. We get x plus 46 equals 90. And 90 minus 46, sorry, brain fried this afternoon, is going to be x is 44. Because 44 minus 4 would give you 40 here, and 50 there would be the complement. So you're going to see questions like those in the back of your homework. A couple more. I'm just going to do number 14. I'm going to take the inside here and the inside here and sum them to 90. So 2x plus 14 plus the x minus 5 adds to 90. 3x minus 9. I'm sorry, 3x plus 9 equals 90, and therefore x will end up being 27 here. So that works with our cofunctions. So again, if you have sine of one angle, cosine of something else, these two values are always going to add to your 90 degrees. Okay. You can keep working through the next couple examples if you wanted. I'm going to skip ahead into our, the rest of our notes for 908 is special right triangles. So we have an isosceles right triangle here, which if I put the right angle, and we know if it's isosceles, these two sides are equal. Therefore, these two angles are 45 and 45. If these two sides are unknown, we could maybe put x with x, and our hypotenuse will always work out to be x squared root of 2. And I can verify that with the Pythagorean theorem. X squared plus x squared equals c squared. We're trying to find out c. Combine like terms, 2x squared equals c squared. You divide by 2. X squared equals c squared divided by 2. And we square root both sides. But the deal there, you have to rationalize. So square root of 2 over square root of 2. We get c radical 2 over 2.